Welcome to the Mr. Smart Maths channel, and my name is Mr. Smart. In this video, we're going to be looking at mean absolute deviation, or MAD. So here we have the ages of 10 people that attended a party. And the first thing we're going to do is we're going to work out what the mean age was. So we're going to add up the numbers 1, 4, 7, 7, 8, and so on, and then divide that by how many people there were, which was 10. So on my calculator, I can see that the sum of those values is 250. So I'm going to write that in to my table. And then take 250 and divide it by 10, because that is the number of people that we have in our sample, and that equals 25. Okay, so that is our mean age. Now that we've worked out the mean age for the 10 people, we need to work out something called the deviation. And the deviation is the absolute value of the distance between each of the ages and the mean age in this case. So what do I mean by that? In the first value, we have a value of 1, and 1 is 24 away from 25. There is a difference of 24 there. So the deviation becomes 24. Let's take another value, 38. 38 is actually 13 more than 25, but because we're looking at an absolute value, the distance between 38 and 25 is 13, and so the deviation is 13. So we take those values and we add them up and find the mean of those deviations. Okay, so in the calculator goes all of those values, and you can see that the answer there is 208. And if I take 208 and divide that by 10, I get 20.8, and that is my mean absolute deviation. So the mean absolute deviation has an actual formula. Here is the formula, and we're going to break it down into the different sections so you can see what the formula means. Okay, so MAD, which obviously stands for the mean absolute deviation, equals. Now we have this sign in yellow, which is sigma. That stands for the words the sum of. So we are adding numbers together. Which numbers? Well, we're going to start with the actual values themselves, and then we're going to find the difference between those values and the mean. And because we said it wasn't a mean absolute deviation, we need to find the absolute value of those. So if the difference between the values and the mean is negative, then the mean absolute value becomes positive. So let's have a look at another example. In the first table, we have exactly the same data as we had in the first example. In the second table, we have another 10 people that attended another party. And we're going to look at the mean and absolute deviation of those 10 people. So firstly, we need to know the sum of those 10 people's ages. So we add up 21 and 21 and 22, 24 and so on. And the sum of those ages is actually also 250. Okay, so that is our total. And then the mean is going to be 250 divided by 10, which is 25. So for both sets of data, the mean is exactly the same. Let's have a look at how the mean absolute deviation changes. So firstly, we're going to need the deviations from the mean. There they are, 4, 4, 3, 1, and so on. And if we add up those deviations, we end up with a total of 24. Okay, so my total of those deviations is 24. And if I divide 24 by 10, then I get a final answer of 2.4. So the mean absolute deviation of this set of 10 people is only 10.4. So you can see, depending on the data, even if the mean is the same, the mean absolute deviation may be different. And that's because in this case, these ages are more spread out compared to the mean age of 25. And in this set of data, the ages are less spread out compared to the mean. So the mean absolute deviation gives you a numerical value for that spread of data. Be sure to check out the Mr. Smart Maths channel on YouTube, and don't forget the website, mrsmartmaths.com. See you again soon.